Welcome to qnawire.
The gauge pressure in a helium gas cylinder is initially at 32 atmospheres. After many balloons have been blown up, the gauge pressure has decreased to 5 atmospheres. What fraction of the original gas remains in the cylinder? So we're going to start from our ideal gas law. So pressure times volume is equal to number of moles times the gas constant times the temperature. By duplicating this and dividing through by the original, we can make the following equation. So P1 over P2 dot V1 over V2 is equal to N1 over N2 dot T1 over T2. Now, in this context, we aren't given any information about the temperature, so we're going to assume that T1 equals T2, so that can be cancelled out. Similarly, the gas cylinder is still a gas cylinder, and we assume that the shape of that doesn't change, so the volume V1 equals V2, so that can be crossed out. So we have the P1 over P2 is equal to N1 over N2. Now, P1, or our original gas cylinder, well, the gauge is given by 32 atmospheres, but the gauge pressure is just a relative pressure. So we've got to remember the atmosphere is at 1 atm. So that gives us P1 is equal to 32 plus 1, which is 33 atm. And similarly, when balloons have been blown up, pressure 2 is given by 6 atm. And so that means that the ratio between the final gas is actually N2 over N1. So we're just going to flip that fraction. So what we really mean to write up is P2 over P1 is equal to N2 over N1, because so if we can do that by multiplying through by N2 and dividing through by N1, and similarly dividing through by P1 and dividing through by P2. It doesn't really matter. It's just because we're looking at the fraction of remaining gas, so it'd be N2 over N1. So N2 over N1, which is the fraction of remaining gas over fraction of original gas present, is equal to 6 over 33, or divide both sides by 3 is equal to 2 over 11.